The modern workplace is undergoing a structural reorganization. Artificial intelligence has moved past simple task automation. It now actively participates in the daily workflow. We are now dealing with Agentic AI. These systems possess autonomous decision-making capabilities. They adapt to changing conditions on their own, operating beyond predictable programming. This sudden shift toward autonomy causes severe psychological displacement among employees. When a system acts independently, it disrupts the traditional behaviors, hierarchies, and expectations that professionals have relied on for their entire careers. The immediate reaction across industries has been panic. Professionals try to regain control by relying on informal trial-and-error prompt templates they find online, often with highly uncertain pedagogical or practical value. Surviving this transition requires a change in perspective. We have to stop treating AI as a standard software application and start recognizing human-AI collaboration as a profound epistemic challenge, a completely new way of managing knowledge. Prompt engineering is a structural discipline. Success depends on the user's ability to navigate the system's underlying logic, rather than simply mastering syntax or grammar. It is a distinct form of digital literacy. It demands a deep structural and critical understanding of the systems we are trying to direct. Look at the difference between these two systems. On the left is the outdated deterministic model, where one specific input always yields the exact same fixed output. On the right is the reality of generative language models, which operate as a probabilistic decision tree. A single input blooms into shifting, multi-path branching outputs. Successfully navigating that probabilistic tree means ensuring the output remains relevant, accurate, and safe. Doing so requires a structured, multi-dimensional competence model to consistently guide the AI's behavior. Without this literacy, educators and professionals will remain misaligned with the agentic tools they are trying to manage, leading to erratic results and mounting frustration. We break this literacy into a three-dimensional framework. The first layer is the cognitive dimension, developing an accurate mental model of how language models operate beneath the surface. Users must recognize them as probability-based text generators, calculating the most likely next word, not intelligent agents. A major point of failure in professional settings occurs when users anthropomorphize the AI. When a human assumes the machine possesses logic, they give it vague instructions, expecting it to understand their intent. Because it is a statistical model, the user's prompt design directly dictates the context sensitivity, tone, and scope of the output. The math only responds to the exact phrasing provided. Applying specific constraints, such as requesting a 10-year-old summary instead of a graduate-level explanation, reorders the statistical weight the model applies to its output. A flawed cognitive model guarantees absolute failure. Even perfect technical typing skills cannot fix an underlying misunderstanding of the tool's nature. The second layer of our framework is the technical dimension, involving the specific tactics used to interact with the model. It isn't about fast typing. It's the practical ability to formulate, test, iterate, and chain complex prompts together to get a precise result. Users have to transition away from simple, single-line search requests. Effective formulation strategies involve assigning role-based constraints, like instructing the AI to act as a strict editor, and using modular design to build reusable templates. This table summarizes specialized task categories in educational settings. Tasks like assessment design and critical thinking, or Socratic tasks, demand highly structured, goal-oriented prompt templates, rather than simple, generic, open-ended queries. Utilizing structured models, such as the CLEAR method, which emphasizes being concise, logical, explicit, adaptive, and reflective, gives users a systematic way to test and refine their outputs until they hit the mark. Another key technical skill is called chaining. Instead of asking the AI to complete a massive objective in one try, the user breaks the work into smaller, sequentially prompted subtasks to carefully guide the AI's logic. Through these methods, technical competence becomes the mechanism that transforms erratic, hallucinatory AI behavior into reliable, structured, and usable data. The final and most frequently neglected layer of this framework is the ethical critical dimension. It acts as the protective boundary around the entire process. This dimension ensures the responsible, reflective, and protective use of the AI's generated outputs. Large language models are trained on human data, which means they carry human flaws. Poorly engineered prompts carry a severe risk of generating biased content, reinforcing societal stereotypes, or marginalizing specific perspectives. The professional must act as a strict pedagogical filter between the raw AI output and the final learner or client. You cannot pass generated text straight to an end user without evaluating it for fairness and accuracy. There is also the existential threat of de-skilling. If professionals over-rely on AI automation without active critical engagement, they lose the very expertise that allows them to evaluate the machine's work in the first place. This extends to complex challenges around academic integrity. Using an AI to generate student feedback or professional evaluations raises serious questions about authorship, originality, and the value of human assessment. Navigating these complex issues requires absolute transparency. Professionals must make the exact nature of AI involvement explicit to their learners and clients, actively modeling what ethical use looks like. These three dimensions are now entirely interdependent. A cognitively accurate and technically perfect prompt is actively dangerous if it lacks the ethical guardrails required to protect the final audience. To move this three-dimensional framework from theory into daily practice, we have to look at how these layers interact during specific tasks. This is the Prompt Engineering Competence Matrix. It serves as the operational blueprint for this new literacy, mapping daily pedagogical tasks against the three dimensions we just built. Let's isolate the row for providing feedback to students to see how the matrix functions in action. Under the cognitive column, the professional must interpret exactly how a prompt's framing influences whether the AI delivers feedback with a helpful, formative tone or a rigid, summative one. Moving to the technical column, they must design highly adaptive, modular prompts that are explicitly built to incorporate existing rubrics and grading criteria. Finally, the ethical requirement dictates that the educator maintain strict transparency about the AI's involvement, carefully avoiding the depersonalization of student support. By breaking down tasks in this way, the matrix bridges the gap between abstract theories of AI behavior and actionable, daily professional execution. This structure isn't just a guide for individual users. It is built to be deployed at scale across entire organizations. Institutions and universities can use this exact structure for rigorous curriculum design, professional development, and creating standardized tools for self-assessment. When Agentic AI first enters a workspace, the autonomy of the machine inevitably creates intense psychological displacement. This displacement stems from the unpredictable nature of an autonomous system. This matrix provides a systematic method for diagnosing AI behavior and correcting its outputs. By replacing trial and error with a repeatable three-dimensional process, professionals gain the structural control needed to manage agentic tools with precision. Integrating these skills establishes the professional as an architectural mediator who sets the boundaries and goals for the AI's computational work. True AI literacy ensures educators and professionals continue to direct the tools of the future, rather than being managed by them.